Alright guys, so this is the second video for 2-4 and we're still dealing with graphing equations that are in slope-intercept form. And so your I can statement here is I can graph a linear equation in slope-intercept form two different ways. We're going to talk about those two different ways. You've done one in the past, or actually, excuse me, you've done both of these methods in the past, and now we're going to kind of compare them together. Agenda, we're going to review the nature of a line's slope, so kind of remind ourselves what that means. We're going to review the nature of a line's y-intercept, and then complete two example problems. Let's get started. Alright, so what is a line slope? Well, I've got this line here, and I've graphed it in red, this line right here. And the equation that describes that line is listed up above. Remember, this is the form y equals mx plus b of any linear function. In this particular case, m, the slope, is -2, and b is -3. Notice it's -3 because it's -3. I had a few questions on that, and it's because if you insert for b a negative number, like -3, this negative and positive cancel out to just a minus sign. So that's why a plus a -3 is just -3. And that's how I know that the that the y-intercept is here at 0, -3. Think about this for a moment. If we plugged in 0 for x, what would y be? Well, all of this stuff here, -2 times 0, goes away. We just have 0. And so y would be 0 minus 3, or -3. So our point for this is 0, -3. That's the y-intercept. That is where we find this red line crossing through the y-axis, and that's why we call it the y-intercept. Now from this particular point, once you've identified that point, you can use the slope right here of -2 to identify other points in the line. Notice, I'm going to write the slope down here, m is -2. I can write any slope as a fraction, or any whole number as a fraction. The negative sign only affects the rise portion. The run portion, because if you remember, slope is rise over run, the run portion can always be thought of as going towards the right. So from this point here, and I'm going to go to the color yellow here, from this point here, I run 1 over to the right. That was my run, it was 1. But my rise is -2. So instead of going up 2 like I would if it was a positive slope, I've got to go down 2. And so as you can see, that's where my next point was made. Again, I can do it. Over 1, down 2. Over 1, down 2. Now I have 1, 2, 3, 4 points, and I simply connected those points with a line to get this red line. That's just a quick recap of how we can go about using the slope and the y-intercept to graph a line. Alright, let's do two quick example problems here. Alright, here are the directions. Graph the line using a function table, and then graph the line simply using the y-intercept and the slope. The lines should look identical. If they don't, find your mistake and fix it. So in this first method, I'm going to use the function table like we learned in the past. And for these problems on your assignment, you're going to have to do this both ways. So I'm going to plug in some x values. I'm going to plug in -2, I'll plug in 0, and I'll plug in +2. So y equals 3 times -2. And so y must equal then -6. So I have this point here, -2, -6. If I plugged in 0, I'm going to end up getting just 0, because 3 times 0 is 0. Notice in this equation right here, y equals 3x, there is no b number. It's because the b is 0 plus 0. So the y-intercept is 0. And we'll talk about that in a moment. So let's plug in 2. Y equals 3 times 2, or 6. So now we have 2, 6. When we go to graph these points, notice that we can identify the y-intercept simply because there is no b value. And so that must mean we start here at 0, 0. That would take care of this point here. -2, -6, and 2, 6. Once I have those 3 points plotted, it makes it really easy now for me to simply graph this line. Let's see if I can get it graphed somewhat correctly. Oh, and my color is kind of weird. Let me change the color. Maybe I'll use red. Okay, let's try this again. That looks kind of strange, but anyways, that would be the line. All right, let's do the same equation in a slightly different way. Instead of using a function table, I'm going to ask you to do the same thing but use a slope method. So first, identify what's b. This is y equals mx plus b. B must be 0. Therefore, it intersects the y-axis at 0. Then from there, I use the slope. My slope is 3, or m is 3, so that must be 3 over 1, or a rise of 3 and a run of 1. So now I come over here to my y-intercept, and I go up 3, 1, 2, 3, because it's positive, and over to the right 1. Remember, the vertical change is affected by a positive or negative sign. So positive means up, negative means down, but the run is always to the right. And so I do that, and I make my points, and now it's really easy for me to graph them. And then the directions say compare the two lines. Do they look the same? Yes, these look identical. They have the same slope. They have the same y-intercept. This one looks a little steeper because I was off just a little bit when I drew my line, but they're the same line. And so I know that I've done both methods correctly. One more quick example, and I want to try and hurry this along for you so it's not too long. But in this particular case, I've got a negative slope and it's a fraction. So I'm going to be careful what values I pick for x. I'm going to pick, I'm going to pick negative 3, I'm going to pick 0, and I'm going to pick positive 6, okay? So if I plug in negative 3 here, I get negative 1/3 times negative 3 plus 4. And all of this equals, and what I'll do here is I'll erase these values so I can kind of show you the math on this so it makes more sense. The next step here would be negative 1/3 times a negative 3 over 1, so I change this into a fraction, plus 4. What I end up getting here is I end up getting a negative 3 over a negative 3, or 3 over 3, which is 1, plus 4. And so now what I have is 1 plus 4. And back here, if this negative 3 over negative 3 confused you, it's really just a positive 3 over positive 3, because any negative divided by a negative is a positive. So in this case, y must equal 5. Okay, so when x is negative 3, y is 5. Let's get rid of all this math so we can do the next point. Sometimes fractions make it a little harder, but it's still just basic math. There's nothing inherently confusing about it. You just plug it in and multiply. So negative 3, 5. Okay, plug in 0 now. Negative 1/3 times 0 is 0 plus 4, so we're just left with the 4. So 0, 4, and that's what we would expect our y-intercept to be right here. Okay. Now we plug in a positive 6. So y equals a negative 1/3 times 6 plus 4. Again, I'll show you the math on this. So y equals negative 1/3 times 6 over 1 plus 4, or a negative 6 over 3 plus 4, which is a negative 2 plus 4, which leaves us just with 2. And I know I went fast through that, but that's the line of logic here on the math. So when x is 6, y is 2. So we have the point 6, 2. Now I can quickly graph all these points. Okay, negative 3, 5. I've got 0, 4. And I've got 6, 2. As you can see, it's not that steep of a line. It's because the slope number's not that big. I mean, it's just 1/3, and we've been dealing in the past with some pretty big slopes, like 5 or 6 or something. Ooh, that's way off. Let me delete that and try that again. But anyways, you'll notice it's not that steep of a slope, which is kind of interesting, I think. See if I can't do this better. Closer. Okay, so not very steep. It's sloping down, so we know that it's negative, and so that fits what we thought, and the y-intercept fits as well. So that makes a lot of sense. Let's finish this off, though. This way, I think, is easier. I'm going to ask you to do it both ways, but this is kind of a sweet way to do it. All right, the y-intercept here must be 4. So 0, 4. Put a point. Let me clean that up a bit. All right. The slope is negative 1/3. So a negative 1 over 3, or rise over run. Remember, we start at this point. We always run to the right. So we're going to go right 3, 1, 2, 3. But then we're going to go down 1 because it's negative. 1, 2, 3, down 1. 1, 2, 3, down 1. As you can see, this line is going to look just like the other line we graphed, if I can figure out how to connect these points. Let me give it a try like that. All right. Not too great, but not too bad. So if we take a look at both these lines, they look the same. That means we must have done it correct. If they're different, you need to figure out where you made a mistake and fix it. So on the worksheet, I'm going to give you equations like this. I'm going to ask you to graph it two different ways. First, use a function table. Second, use the y-intercept slope method to find your points. And if they match, you know you did it right. All right, guys, good luck on the assignment. I know you'll do great.